Good afternoon, everyone. Thank you for joining today's session. Uh, my name is Murtaza, and I'm the Education Director at Robots Got Talent. We have put together two fun days called Arduino Days, and this is to celebrate the 20th birthday anniversary of Arduino. I have along with me our team, our founder Youssef, our marketing director Sandipan, and our educational uh, curriculum lead Abdelaziz with me to help me with today's day. Arduino is not new in the education system. It's been there for a while. And hands-on learning hasn't been new. If you go back all the way up to 1960, Samuel Paper wrote a paper, if you guys remember the Turtle programming language or the Logo programming language, that was right in 1960, where he wrote about hands-on learning, and he came up with this concept of constructivism, where your hands learns much better when you do with your kinesthetic work. But then after that, there was a small dip from 1960 to 1990s where there was not really any hands-on learning happen till the time where Arduino 20 years ago started this whole movement of physical computing and learning through hands-on and simple like Lego-like programming language. And over the last 20 years, Arduino has seen different versions of the kits come up, and we're going to explore a few things today. So today is day two. We're going to look at session one with show and tell of Tankbot and Humanoid, a basic Arduino circuit and programming, and introduction to IoT principles. The new IoT cloud platform will then come in later in session four. Then in session two, we look at hands-on Arduino basic concepts with Master Abdelaziz, and he's going to show you very quickly how Arduino can then be used to explore sensors and understanding inputs and real-world application. Session three is more about what's Arduino's role in education, like what are its building blocks in education, and how you can use it in your ICT classes, in your science classes, and what are the learning materials available and teaching strategies for that. And session four will be on the IoT cloud, a quick hands-on demo on IoT cloud capacities with a simple connected project. We'll then open up the stage for question and answers and end up with Arduino birthday celebration. So this is the first year Arduino days are happening over 2 days, and day two is considered as an open source day where the community comes together, the makerspace, educators, hobbyists all come together and share their projects. And this is happening in almost 167 locations around the world. So thank you for joining us today. And with that, let's start off with session one, show and tell. So I'd like to invite Sandipan and Youssef on, on the stage.
Yes, I'm Sandipan, so I'll take over. Thank you, Murtaza. Could you hear me?
Yes, we can hear you, Sandy.
Okay, I'll take over and I'll present my presentation from now on. Thank you again and again. Let me present. Okay, so I'm Sandipan. As you know, I was a speaker yesterday too. So this is session one, show and tell, where I'll be talking specifically about TankBot, what I have made, and along with that, I'll be explaining how I made, how you all can make it at your space, and also I will be showing again how that robot, the tank bot, performed in real time applications, and also when we try to execute it and when we try to experiment with that. So we'll be talking about all through this. Let's deep dive. So first, um, let's talk about, let's learn a little bit about what is robot. So we all might know that robot is something that we program and set some instruction to that through microcontrollers or single board computers or processors, whatever you're using. We just set some programs. It is pre-programmed, and we will set some instruction that the robot will follow. So that is robot in brief. Now, usually as we are talking about Arduino here, so we'll be talking how we can make a very kind of professional robot with Arduino. So now let's talk about how robot works. So usually robots are kind of pre-programmed. Um, we can think of robots as a project that can move, that can either talk or can show some expressions, or maybe we have all known about these uh, Sophia, which is very popular humanoid robots, or Ameka from United Kingdom, or Erika from Japan. So these are really popular robots all over the world. Even Sophia was the first robot to get citizenship from UAE. So these are the robots we all know about. But there are also other kind of robots that we don't even know much about, like the robots, mobile robots that works 24 into 7 in factories, like Amazon factories or any other kind of giant e-commerce factories, or the robots that uh, makes that help us make or that build cars, motorcycles, or manufacture help us manufacture a lot of things that we human are incapable of doing it in just few hours. So they make easy for us to automate everything. And once we build that setup, they will do everything for us in just few hours. So now let's talk about what are robots or the type of robots. So as I talked about humanoid robots like Sophia, Ameka, Erika, and there are so many. So there are humanoid robots, and agricultural robots. There are so many agricultural robots. They are not that popular though, but we still use them in various countries. There are cobots who are kind of robotic arms. They do some specific tasks, and they are really efficient at that. But for that particular task only, they are not multi-role robots. And industrial robots, as I talked about, those robots who help us manufacture things or help us manufacturing cars, motorcycles, bicycles, or whatever we can think of. And then we come into medical robots. Medical robots, as we know, the robots that helps us operate human very efficiently, even though they are on trial till now, but they are also getting to use. And in next 25 to 30 years, I think 50% of operations will be done by robots only. And then we are into soft robots. Soft robot is a part of robotics that uses soft tissues, artificial tissues, or soft artificial materials that can be used even inside our human body. So these are the robots that are soft robots and can change even their shapes. So we these are not really popular robots. These are under working till now, and there are a lot of research going on. If we just search on Google, we'll find a lot of examples. And the nanorobots. Nanorobots are the future of robots, where we are trying to make it very, very, very small that we can't even see them with our naked eyes. And we are trying it to, for example, I'll give you an example, an easy example. Just think the medicine we take. So instead of medicine, we will be taking a nanorobot, and will be the robot will go inside our stomach, and it will find all the problems we have, and you don't need to operate at all. Will The doctor will set the instruction, or maybe control it manually from outside, and the robot will be doing everything the doctor wants to do inside your body. So it will be really efficient, and there will be no errors at all, because they will be so precise. So these are robots. And there are a lot of categories, but they are not that popular, so I haven't mentioned here. And then let's talk about the robot use cases. So industrial automation, as I have mentioned here. So I already mentioned like assembly lines where we create like a lot of companies like Honda, Hyundai, they usually use robots 80 to 90%. So you can imagine robots are making those manufacturing so faster, easier, efficient, and error-proof. And then welding, of course. And there are also robots are coming out. They are doing paintings. They are doing packagings. They have been creating the whole automation for bakeries, creating foods and all. Even there are robots that can provide foods. If you think about Japan, there is a hotel which is completely humanless, only robots. So even the waiter from the um, safe, from the toilet cleaner, everyone is robots. You will not find any human except if there is any issues. Even the worker are there, all are engineers, not any specific general kind of people who would usually work in um, hotels like that. And then we'll find healthcare and medical robots, as I have told, surgical robots, and some. There are some research going on where we don't need any kind of X-ray machines. We'll be sitting in a room, and the robot will be checking our full body or scanning our full body in just 10 minutes, and in 15 minutes, in just less than 30 minutes, you'll get all the reports and all the problems you have in your body. They will be giving you in just fraction of minutes. So you don't need to have blood collections, blood taste, these, that. You don't have to do anything. You just sit, and they will be giving you all the problems you have in just fraction of minutes. And all the problems, I'm not talking about specific problems, because nowadays if you have some specific problems, you need to do blood test for that. That takes around like 1 2 days or even a few hours just for one particular test. So that will not going to happen if we have robots. And then agriculture and farming, where we have autonomous tractors to get the crops and the seeds, plants, and they cut the trees, and they do it very fast, that we humans are incapable of. And then they monitor crops too, and also they do harvesting by themselves with human supervision sometimes, yes. And as we all know, military and defense are using and investing a lot into robots. Future gonna be for robots, that's for sure. So they are doing surveillance as robots, they are doing bomb disposal, autonomous combat drones. They are also making autonomous robots, tanks, a lot of things. And then we have robots for search and rescue, where to disaster response. For example, if there is some floods and there are some people stuck at some specific point, and we human are incapable of going there, what we used to do is to get helicopters, but that's really expensive. So if we have drones, we can just go there, find them with camera from drone from any other place, like beyond visual line of sight, BVLAS, and then we can send them some, drop some foods or some life jackets so that they can come. Or maybe we can just give them some, we can some give them message, voice message from the drone, and they can at least feel assured that we'll come to help them out. And there are robots to fight fires, there are robots to explore mines, and etc. etc. And also there are robots, logistics and warehousing, as I have already mentioned. Amazon and Temu and Alibaba use robots all the time. Even in some countries, they do drone deliveries. Even There is a country in Africa, they are doing it very efficiently. I don't remember the name, but they are really doing efficiently, and they are doing it hundreds of times every day. And also, as we all know, Tesla and self-driving cars, I don't have to talk about that. Maybe all of you, most of you, or maybe some of you already rode that car. Um, so we all know about self-driving, and I think it will be the future very soon. And I must explain that Tesla, Waymo, these companies are really leading out, uh, besides Chinese companies and Singaporean companies for self-driving cars. And then we have robots for space exploration. I don't have to explain much. We all know about Mars rover from NASA, so they are really doing it good. And also autonomous vehicles, like as I've already mentioned, self-driving cars, robotic public transport like bus, or maybe there will be some autonomous kind of cars in next 30, 35 years. And even we are getting to see some autonomous motorcycles, some autonomous bicycles. I have some videos I may show you later. So this is what I chose to talk about today, Tangbot, what I have made. The chassis were not made completely designed by me. These were something I grabbed up. But this is how it looks, and this is the photo. You can see this is the chassis that is totally metal, and we can. It is really rugged and very heavy because it can do a lot of tasks. What I'll be talking very soon. So this is the photo. And now let's talk about what is TankBot and how it is different than other robots. So as you can see, the difference between this robot and other robots we usually make is the wheel. So we have kind of different wheel here, uh, like continuous track or what we say conveyor belt, which we usually see in military tanks. And we try to we try to uh, duplicate it or clone it to use it in a very scale model where we can find that same type of capacity to overcome obstacles, and we can use this robot in various rough surfaces where the normal robot can go. For example, the muddy places or the wet places or very dirty places, or where there are very so many sands like deserts, or maybe so many dirts. So these kind of places we can use it. Even it can be made waterproof, dust proof, and it can even run in some little or light rains, rainy season or rainy places. So that can be used. Even though the one I have made was not completely waterproof because I it was not completed at that time, so I didn't make it waterproof. But yes, that can be made. And now let's talk about how to build robots with Arduino. As we are talking about Arduino here, so Arduino, as you all know, Arduino provides a powerful, accessible platform for building robots with the IDE and all the choices of Arduino family boards. And it really makes anyone, like beginners, even those who are not from science fields, they can also use Arduino easily with just few tutorials what we provide from our RGT side. You can easily learn just in 7 or 10 days if you are really looking into those courses. We really have awesome courses created by Abdelaziz, so you can just look into that, and I hope you will all love it. It is really instructed in very simple words. It will be easy for all of you who are starting or getting started or thinking to get started. It will be really easy for you, all of you. So yeah, what we use, some motors and the chassis and some programming instructions, and all of that's how we made robots. So this is just a brief part. I'll be explaining step by step how we made this tank robot or how you all of you can make it. So let's talk about that, how to build TankBot. So first will be we need to plan and design the robot, how the robot will look and how the chassis will look. So we have to choose a type of robot first. Like we'll be for TankBot, we'll be choosing that conveyor belt mechanism for the wheels and a rectangular shape for the chassis. And then we'll need to choose what MCU will use. So for now, let's assume we'll be using Arduino Uno, even though I didn't use Arduino Uno because of its limited power, but we can think of Arduino Uno for now. And then we have to choose necessary components like motors and sensors if you want to use, and some communication modules if you want to wirelessly communicate with that, with the robot, and want to operate that wirelessly, and power source, of course, which is necessary. And for choosing the chassis, we must think about the material strength because sometimes it happens that the material is not that good. For example, if you use polymer or plastic, it will not work. So it also depends on the chassis materials and strength and also weight distribution because if you don't have managed CG, it won't work well and it will drift when you use autonomous navigations if you want to later. And then we have to talk about assembly and wiring. So once the design is finalized and you found all of the components like chassis, wheels, and motor stuff and everything, you have to assemble. So for that motor, we usually for this tank robot usually use two motors and two wheels, and then for another two wheels we use some false mechanisms to move the wheels freely. So false wheels we usually say that. And for the motors to work, we must need a motor driver, which you can think of L298N, which is really easy and cheap and very popular. And then we have to think about sensors if you want to attach like ultrasonic, infrared, or IME sensors, or even GPS. And GPS is not a sensor. GPS and communication modules like RF or NRF or Wi-Fi, Bluetooth, whatever we want to use. We have used RF, and we actually made it autonomous too, which I'll be showing later. And then we have to choose about Arduino board, what you are choosing, like Nano, Uno. For now, we thought to choose Nano. And then power management, we have to choose a battery pack. What I prefer is LiPo packs, which is really uh, less in weight and also very good, even though a little bit expensive, but yes, LiPo is good. What I choose 3S LiPo and around 500, 200, 5,200 or you can use anything, but 5,200 what I've used, and I also recommend that for good amount of battery backups and communication. For that, you can use I have already mentioned. And then now the part we have come into programming the part, how we program. So for motor, we have to use PWM signals to control the speed and direction using L298N, and then data processing. If we want to use any kind of obstacle avoidance systems or like that, we have to read the sensors data and calculate the distance, and then making decisions uh, according to that if something is in front of not or not, and if you want to take left, right, or go back, and then or maybe just completely turn like that. And then wireless communication again, you have to think about if you want to control it yourself or if you want to make it completely autonomous, like I did. And then you have to fine tune the performance, like adjusting parameters, variables, and everything to make it smoother for real time. Because in the robotics world, simulations and real time operations are completely different. If we think that if we do simulations, we are experts. No, no, no. Real time operations are completely different than just simulations. So we can't never depend on um, we can never depend on simulations for robots. Now let's talk about obstacle avoidance and path finding. As I already told, if we want to use obstacle avoidance, there are so many obstacle avoidance algorithms. We can use whatever we want for the navigation and make it a little bit kind of autonomous or give it an extra advantage. Now we come into the part of testing and debugging. After we do all of this and after programming the robot, we'll be checking if the robot performs as we expected. Like we'll be checking basic movement tests, um, like basic movements. Like what do you think of basic movements? Forward, backward, left, and right. Because we are using just conveyor belt system here, so we cannot expect what we expect from omnivores. So no, that can be done here. And then sensor accuracy. If we are using sensor, we have to check all the necessary sensors are giving response well, what we have expected, and don't have any garbage data. And then we'll be checking obstacle avoidance performance, if it is taking decisions well or not in real world. And also we'll have to check the reliability of communication, wireless communication. We don't want the robot to be lost. So yes, that is important. And for example, if you're doing some risky operations or sending the robot into somewhere we can't go inside, so if the communication is not reliable, we'll be losing the robot. And then power efficiency, we have to always calculate how long we have battery backup so that we can go. For example, if we have 25 minutes battery backup, we can only send the robots for like 15 minutes maximum because we need time to make the robot come back to ourselves too. So we can't go all the way to 25 minutes just to send the robot. Then we can't get the robot back if we are doing it wireless operation. And then you have to think about how we can enhance the bot if everything is working perfectly. Then we can think of adding AI or machine learning using Raspberry Pi, JSON Nano, JSON Nano, Poly Nano, like that. Or we can use some computer visions using camera and OpenCV like that. Also, we can use IoT where we can uh, if we use IoT, we can use this robot. For example, let's say we are in New Zealand and we want to use the robot in United Kingdom. We can use it using IoT. And then we can think of autonomous navigation. What I have specifically done, is I have implemented GPS and compass. I didn't use LiDAR. LiDAR is especially for indoor, but also we can use outdoor too. Those are different. But I have completely used GPS and compass to make it autonomous. So I'll be showing that later. And also you can do some little changes for the design if you want to do it again and do some upgrades, minor upgrades, and make it much better. Now, what I was talking about, I'll be showing how the robot uh, takes or uh, all the instruction first, and when we start the robot it will be going low speed, sometimes it will be going high speed, and it will be doing everything autonomous. The video I'll be showing, we haven't done anything, we have just programmed it and it will be going somewhere and coming back to us autonomously. So um, I'll be stop sharing and I'll be playing the video. Um, Yes, so that was the robot. You can see the GPS mounted there, and it is doing autonomous operations. We are just taking the videos. We are not controlling it at all, and it was doing everything itself. And you can also see the environment. The surface was not good. It was getting stuck sometimes, and it was already trying to do everything itself. Yeah, as you can see, maybe we'll be helping it a little bit. Okay, sorry for that. We had to help a little bit. Uh, oh, okay. This was not okay. This was a little bit different because we didn't have conveyor belt there. Sorry for that. We didn't have any conveyor belt system. That's why we had to help the robot. But it is similar platform. We just had different wheels. If it would have a conveyor belt system, then we didn't have to help the robot get out from that place. Yes, that was our place where we wanted the robot to go, and it was going. And now I'll be showing the robot physically, like I did yesterday with all of you. So, okay, now can you see the robot? This is the robot. Please let me know if you can see it well, or maybe I'll have to stop the effects. This is the actual robot with conveyor belt. And the video I have shown was also this platform, this specific platform, but there was no conveyor belt only. There was just normal rugged wheels. And that's how we almost ended the presentation from my side. And I also want to mention that thank you again to Mr. Youssef, uh, uh, who is founder of Robots Got Talent, and Murtaza for helping me out, and also Abdelaziz. He has done a great job too. And as all of you know, I was the speaker and also founder of DreamsAI and head of the events of RGT. And I also wants to say that happy birthday, Arduino, and thanks for joining me. Thanks for listening to me. Thanks for your time. And yes, thank you, all of you. And there will be, after the session, there will be Q&A, and all of you can ask me any questions you like or anything, not only specific about tankbots. If you have any kind of ideas you can share, or you want to share, or you want to ask about anything about your personal process, you can ask me. Thank you. I'll request Murtaza to take over. Thank you, Murtaza, and thank you, Mr. Yusuf.
Thank you, Sandipan, for this lovely presentation. Love the tank bot and
Thank
uh,
you.
the whole journey of how you've designed it from start. Know what parts to use, what components to use. That was really informative. Thank you so much, Sandipan, for sharing all your knowledge with us. I
Thank
would
you.
like
Thank you.
to now invite the founder of Robots Go Talent, Youssef Osman, joining all the way from New Zealand to share with us his expertise.
Hello? Hello?
Hi,
Can you
Youssef.
hear me?
Yes, we can hear
Hi,
you.
Murtaza. How are you?
I'm good, thank you.
Great. Thanks for the great job that you've been doing and for hosting this meeting. Thank you, Sandipan, for doing this great presentation. I really loved the tank bots and the drone from yesterday as well.
Thank you. Thank you. Thank you so much,
So,
and welcome.
you're welcome. Thank you. Again, thanks for everyone who's joining us again today. I really appreciate your time and effort and interest in learning something new and exploring the worlds of Arduino. So, just maybe let's try some guesses. What else do I do in my life but robotics? Well, I build animatronics. It's not that different from robotics, but that's another thing that I do in my life, just building animatronics. So right now, I'll deliver a bit of a presentation about what I call smart animatronics, or how animatronics have transformed from the old pneumatics and the air powered and the fluid powered machines used in films and amusement parks to electronics, so something that you could just use a microcontroller with and a fully functioning animatronic. And we'll explore a few examples. I'll also show you a few projects that I've done. So I hope you're all interested about this. I'll be sharing my screen right now. So can you all see this?
Yes, we can.
Is the presentation? Yeah, awesome. Thank you. So that's just a little presentation about animatronics and the project that I've done, which I like to call IoT animatronic. Let's see what does that mean. So for those who haven't heard about the term animatronic before, or like what's our animatronics, or what's the machine or the device or the robot maybe that you could consider an animatronic. So animatronics are puppets or models which are like controlled electronically in order to move. Most of their applications were in films, theme parks, or mainly like entertainment uses. Uh, so animatronics became really famous in the like 1960s by Walt Disney, of course, the amazing Walt Disney and his Walt Disney Imagineering department, which mainly creates the rides and the all the different attractions, props, and all the Disney parks. So that's why the world's like best animatronics are at Disney World. So believe it or not, those are all animatronics. There are machines in there, a bunch of motors, a bunch of like things going there and fro, and you'll see this extremely natural movements, which is amazing. Of course, there are like other example animatronics. Of course, the famous 𝐀𝐫𝐝𝐻 animatronics, which of course inspired the famous game and movie Five Nights at Freddy's, and the Ninja Turtles live action version by Jim Henson. Okay, so in the old days, or not really old, just like maybe 10 or 20 years ago, most animatronics used to consist of the following components. So the mechanical firmware was like mainly metal or plastic skeleton. So their skeleton was mainly metal or plastic. Back then, when the 3D printing was not really a thing, or it was not really widely used, so it would mainly consist of metal or plastic, and you could all imagine how heavy that thing would be. And for the actuators, or what you call motors, they're mainly like devices which are controlled by fluids or air. So the problem with these things is that they are very like complicated to maintain and repair. But that was the way to do it. There not all things we could have done back then. And the control systems for them are mainly like they have like a defined pre-programmed sequence. So they only have few limited movements that they just like repair again and again and again. So the way that these animatronics are programmed are pretty basic, and sometimes even using ladder logic, the simple logic, like you put 10101, like very, very old school stuff. But luckily that changed. In the past few years, animatronics, you could now actually implement microcontrollers in there. Microcontrollers, of course, you heard this term yesterday. So Arduino is kind of a microcontroller board, so you could implement devices that allow you to program, control motors, read inputs from sensors, and just allow you to be creative with everything that you want from the electronic, mechanical, and software aspect. So with this change, the actuators now could just be servos. For those who are not familiar with servos, we'll be discussing this today, and Abdelaziz would guide you through a few examples. So servos are mainly electronic motors that have built-in encoders. So with servos, you could define how many degrees that you want to move, or how many degrees that this arm wants to rotate to. So that's not the case for DC motors or for stepper motors. Abdelaziz will guide you through this today again. And for the control systems, as I mentioned, now we could just use microcontrollers. With that, you're now like capable of creating more complicated programming, where a lot of people could actually collaborate in this, and you could integrate more things. So if you don't know, like with Arduino, you're just using C++. I remember a project I've done where I implemented Arduino C++ on a just like a grabbing mechanism, and I used like the PC cam with a Python OpenCV code, and I just created a full image recognition portal. So you could just, with Arduino and C++, you have endless possibilities with the things that you could integrate together and the complicated programs that you could do. So as this is mentioned here, for the programming, you could now use C++, C, Python, or some of the public control apps. So yeah, does that sound familiar? We said like actuators, servos, motors. We said microcontroller. We've said sensors as well. And of course, that thing is powered. So doesn't that make it a robot? Well, that's kind of a dilemma, and it's sometimes difficult to define whether this is a robot or an animatronic. So I just want you to think, what could be the difference between a robot and an animatronic? So my way of defining this, if I want to define a robot, it's a machine that consists of 4 different parts or has four different characteristics. So it's movement, sensing, power, and intelligence. So for the movement, it needs to move or move a part of it. Sensing, it needs to sense its surroundings, of course, using sensors or other devices. For power, it needs to be powered. That's simple. For intelligence, by intelligence, of course, we don't mean artificial intelligence specifically, we just mean intelligence in general. So there should be a code with some sort of logic that a robot needs to follow or that this machine needs to follow in order to perform its task. So actually, in most cases, what would let us differ between animatronic and a robot are the two of those like characteristics, sensing and intelligence. So yeah, it's kind of a robot. So for a robot to be considered as an animatronic, it should be designed for entertainment because animatronics are mainly entertainment-based robots. As we mentioned, they're used like in theme parks, they're used like in attractions and films, and a lot of like entertainment use it. They're not really uh, applicable in most of the actual cases. And honestly, that's why I'm not so like amazed by the like late creations of humanoid robots because unfortunately that's not actually reliable. The same task that's a humanoid robots could perform could actually be done by like a basic mobile robot and more effectively. You don't need like a robot to move with legs in order to carry a box. Like you could just do this with a mobile robot and it'd be like 100% better and more safe and more efficient. So, but sometimes they've actually done like great things. I love 𝐀𝐫𝐝𝐿 by Honda. It's a great robot for those who've like checked this. Like I've had the privilege of seeing it in person, like a lifetime experience. It was like one of the first humanoid robots to be built like ever with that amount of difficulty, this amount of sensors, the number of degrees of freedom. It's such an impressive creation, but unfortunately it was discontinued because these kinds of humanoid robots are not reliable. They're magical, they're awesome, but they can't really perform a lot of tasks effectively, which is really sad. So again, for a robot to be considered an animatronic, which should be mainly designed for entertainment, have a pre-programmed scripted movements rather than AI-driven responses, or as I said, logic mainly. It has like basic sensors and limited data collected. So, for example, if we're talking about what is a famous animatronic that you might have seen? So I know like we have a lot of people joining us from UAE. So I've been to Motion Gate a few years ago. They have some excellent animatronics there. So for example, if you're going to the Shrek ride and there's this huge Shrek animatronic waving its hands, do you think that does include like a lot of sensors? It could include like one or two sensors, but the data collected is not a lot and it doesn't really like affect the progress or the like performance of the robots or the animatronic. Then this is considered an animatronic. So yeah, most cases it should be more. It's had like the movement should be more realistic and like it. So as I told you, I love animatronics. 2019, that's like 6 years ago. Wow. I participated in a competition called 𝐀𝐫𝐝𝐿 𝐵𝐵, and that's when I built my first animatronic with the team. So that was a stormtrooper from Star Wars. It's mainly needed, it basically needed just to conduct a show. So of course back then it wasn't really easy to have a 3D printer, so we were just relying on a bunch of different pieces from different sets. Those, by the way, are two different robots. So that's a version, that's the second version. This version was capable of splitting its legs This one was kind of capable of jumping. That's the same one here. As you can see, there are like a bunch of servos, DC motors there, more DC motors, more DC motors. It was an amazing robot, but I thought I could do something better. That was just an animatronic. It wasn't a robot. We didn't have like a lot of sensors there. I think we just had added like a sensor one day before the competition. It was just an ultrasonic sensor, so it was kind of useless. But that's just a basic animatronic. I really want to do something better. So that's where I got this idea. Unfortunately, in 2013, I left Egypt to study here in New Zealand. So back then, I used to like judge and consult in a bunch of different robotics competitions there. So what I thought of doing is just building this replica who could participate in the competition and judge on my behalf. So the amazing thing about this robot is, or this like smart animatronic, it was kind of an IoT device, meaning that I was capable of controlling this while being in New Zealand. So I used IoT Cloud for controlling all of these servos and DC motors. So basically, I was just sitting here in my room, and could just like move this robot forward, move it backwards, and with this screen, I could just open a video call and actually talk to people there in person. It was an amazing experience. And by the way, I want to thank Abdelaziz and Sandipan because they really helped me a lot in this project. So yeah, here is a photo where I look a bit happy. I was just about to cry, I wouldn't lie. That was just the day before I left. So, as I mentioned, an IoT Cloud is like an application of Arduino, or a new platform, which not really new, like let's say relatively new platform built by Arduino, which allows you to control or create Wi-Fi controlled like devices or Wi-Fi controlled robots. Just like think about it. You could be sitting anywhere in the world and you want to perform this thing, or you want to make this robot do that. You could just basically do this through Arduino in the Arduino IoT Cloud. So for this, you mainly need a Wi-Fi compatible board. So that's the R4, I guess, the R4 with Wi-Fi built in, and that's ESP32. So for this robot, I'll tell you the components in a minute. But yeah, it was an amazing project. Okay, so this project was mainly controlled by the Arduino Mega. And with this Arduino Mega, the version that I've had unfortunately didn't have like Wi-Fi built in. So for that, we used ESP32 and did a communication link between the ESP32 and the Arduino Mega. In addition to that, we also had this Bluetooth module for the first version of the robot, just directly connected to the Arduino Mega. Of course, we had 4 DC motors. Yeah, that was a heavy robot. And the motor controller that was kind of capable of driving these motors, and tons of servos. This robot like had, I think, 6 to 8 servos and a lot of degrees of freedom. It was such an amazing project, and I really love doing this. So if you're want to think about the face or the emotions, that was the first version of that robot, the Bluetooth-based version. So there was a Android app that we created where we could just control this animation and control its movement, the movement of the server. And then the second version, or the upgrade, we've just switched to IoT Cloud, where we built our own dashboard with different like buttons, different like on off switches, different the sliders for controlling servos, for controlling the DC motors, for moving this like forward, backwards, for controlling like the arm, the shoulder, everything. So after that, what I really wanted to do was to create a image recognition system via Wi-Fi, where I could just sit here and do this, do that, like talk, and the robot could literally mimic my movements. Unfortunately, back then that wasn't really doable for a lot of reasons. But like, I don't know, like this presentation made me think that I want to do this again. So now the important question: did that all work? Well, yes, it does, but it's abandoned now. Sad. Abandoned animatronics are really scary. It's one of the worst thing ever. So at the end, stay away with animatronics. Animatronics are scary, but they're cool. You could do anything with Arduino. You could build this huge device. You could just think, just there are no borders for imagination. Do whatever you want to do. I hope you've enjoyed this presentation and you are enjoying the workshop so far. Again, thank you so much for joining us. And thank you, Sandipan, Murtaza, Abdelaziz, for all the great efforts they've been doing for conducting this event. I think I'll continue to be here with you through this meeting, although it's like 2 a.m. here for me, but I love staying here with you guys. It's amazing. And I really hope everyone else is also enjoying this workshop. Thank you, Murtaza.
Thank you, Yusuf, for the wonderful presentation. Yeah, it was interesting to learn about animatronics. I had seen the Walt Disney's mechanical bird uh, last year when they had the 50th anniversary, and
Wow.
no, a couple of years ago, I'd gone to a school where they were celebrating Halloween, and what they had done is they had created a big spider, uh, and then they had given it mechanical movement as animatronics. And I just thought, okay, it's a Halloween spider, so it would just not move. So I was walking past it, and then it might have had an ultrasonic sensor. So when I walked past it, it just raised its two legs,
Moved.
and
Yeah.
it shared this. Uh,
Scary.
yeah, it scared me badly. I was walking along with the teacher and I ran from there. I mean, I'm scared of spiders, but yeah, animatronics are
Yeah.
great way for you to understand just design, and not everything needs to be intelligent. It's the whole idea is
True.
Walt Disney had animatronics right from in Pirates of Caribbean, they had it in Avatar, but the whole idea is entertainment. But how can you design entertainment which is sustainable, and they do not know it can convey the message. So Walt Disney used to do a lot of audio animatronic just to make those sounds of animal movements, bird movements to feel real. The more real life you can get, that's the whole idea of animatronic. But thank you so much for
Yeah. Thank
sharing
you.
your
By
amazing
the way, there is
creation.
something that I want to add. I was actually trying to build an animatronic for this presentation, and here is, you can see this. Here it's hand. Here are a bunch of servos, but unfortunately, as usual, my 3D printer broke
Oh,
after
okay.
20 hours of printing. So it just ruined the whole face and the remaining parts of the arm. So shame on you, 3D printer. I hate you. And sorry, guys, for not being able to see this. Maybe next time, or maybe we could create a course, a tutorial, or a competition for animatronics. I
Yeah,
don't know. Thanks again, Mortaza. I'll just leave
thank
you
you,
to
thank you.
continue the meeting. Thank you.
Yeah, thank you, Yusuf, for sharing all of that at 2 a.m. It didn't feel like that. uh, now I wanted to invite Abdulaziz to share his hands-on Arduino basic course. He is a amazing person. He has done all the work behind Robot Got Talent's Arduino course. and he's put a lot of efforts in designing that, right from a student level to a teacher level, the presentations, the animations, the coding. So I want to invite the master himself to share his Arduino Discovery course. Over to you, Abdulaziz.
Thank you very much, Murtaza, for this introduction. You're doing great work. Thank you, Youssef and Sandy, for your great presentation. I really enjoyed it. Um, yeah, so today we'll just continue where we left off yesterday. We're gonna do a quick or a small recap of yesterday, and we shall go into new topics today. Yes, let me share my screen here. Can you see my screen?
No.
I was able to for a minute and then I stopped sharing. Can you share it back again?
Okay. Is it working now? Nope.
Not, no, we can't see a screen yet. So just while Abdulaziz is sharing, we have an Arduino birthday gift for everyone. So the Arduino Discovery course is available on the Robot Got Talent platform. So uh, please feel free to join the course, have a look at all the work Abdulaziz has put in, uh, and do give your feedback after that. Yep, we can see our screen now. We were able to see a screen. I think it's for me.
Is it
It's now.
working?
Yeah, we can see a screen. Yes.
Okay, excellent. So, so yesterday we covered the introduction and the basics. We talked about microcontrollers and the Arduino Uno. We talked a little bit about the Arduino IDE, variables, the basic functions like pin mode function, digital write. We talked a little bit about hardware, LEDs, the breadboard, and the buzzer. So today we will start from the hardware, the DC motors. So let's begin. Okay, DC motors are kind of the muscles of your projects. If you're going to build a small RC car or you're going to build an animatronics like Youssef showed us, there are lots of types of motors. We have normal DC motors, brushed DC motors. We have servo motors. They are considered a DC motor. Steppers. Some of the servo motors are AC, but usually in the hobbyist and robotics world, they are DC motors. They are not an AC motors. So basically, they come in all shape and sizes with different speeds and different power ratings and torques. So your job is to choose the best DC motor for your application. Unfortunately, DC motors they draw a lot of current. They require a lot of power. The Arduino Uno can handle that. For example, in the LED, we just connect the LED to the Arduino through a resistor. That's all what we need. But DC motors, they have coils inside them, so they draw a lot of current. The Arduino can't handle that, so we need a motor driver. They also come in all different shape and sizes, motor drivers. But we in this course we chose the most common one, which is the L298D motor driver. Um, it can support two DC motors. We explained the pin outs, sorry, and how you connect it, what every pin does, and how to read the pins. Okay. We also have some circuit diagrams for every exercise, how you can connect your motor to the L298 chip using Tinkercad. Um, it's also very similar in real life if you have a shield like this. It's just less pins instead of, for example, you need to deal with all of these. You can just deal with 5 headers and you connect your DC motors to the terminals. So in this exercise, we just want the DC motors to start rotating clockwise for 5 seconds. It's a very simple example. We provide the circuitry, and the code, so the student can try and do it. I made a small replica of this exercise here. I connected the circuits because it's really kind of tedious to connect all the pots. I didn't want to delay you guys with this boring connections, so I just connected the circuit, and if you can see the motor start rotating, then it stops. Start rotating, and it stops. So it's very simple. The code, we have the three important pins. The enable pin, the input, the first input pin. This is the enable pin. We have the first input 1 and input 2 pins. Input 1 and input 2 control the direction of the DC motor. And the enable pin, it has 2 functions. It can stop the motor if the enable pin reads 0 volts or it's set to low. The DC motor won't rotate. Whether you put high or low to the other pins, it won't work. It enable the rotation, and it can control the speed of your DC motor. If you want to run at half the speed or at full speed, you can, or anything in between. The enable 1 and enable 2, they control the directions. So the next step after we declare the variables or the pins, we tell the Arduino what to do with these pins. They are all output pins. Sorry, we don't read anything here. So we digital write high to the enable pin, so the DC motor can rotate. If we quickly change it to low here, sorry about that, the DC motor won't rotate. It's not working. It stopped. We can put it back to high. It start working again. So the DC motor is flipped upside down, so it's rotating counterclockwise. So if you want to change that, we go to the input pin, the first one. We just reverse it. We give it a low, and the input pin 2, we give it a high, and it should rotate in the right directions. Yeah. So we explain all of this in the code. And in the further lessons, the next lessons, we explain how to control speeds and direction and what to do if you have more than one DC motor. Also, it's we need the external power supply, the 9-volt battery. It depends on your DC motor. If your DC motor runs on 12 volts, you're gonna need a 12-volt battery, and so on. Also, you need to pay attention to your microchip or the driver. It can handle so much amount of current, so the data sheet will show you the maximum current value that it can handle and maximum voltage. So if you're, for example, the L298 can support up to 24 volts, I think, and 2 amperes of current. So if you give it a 40 volts or 60 volts, it's gonna blow up. So you always need to check your data sheet. Here is another exercise where we ask the student to connect two DC motors and make them rotate counterclockwise, then reverse the direction to clockwise, and so on. After that, after the DC motors, we have the other topics like LCDs and the data types and hardware. Hardware, we talk about sensors. So this, what will we do? Sensors. So sensors are the means or the way that you make your robot or your creation observe the outside world. If it's a temperature sensor, it can sense the temperature, or if it's a light sensor or a proximity sensor or a smoke detecting sensor, they're all types of sensors. It can be a motion sensor, it's linear motion or rotating motions. All of these are sensors, and you can add them to your project based on your specific applications. So in this project, we for the first sensor, we took the temperature sensor. It's the temp 36. It's a very basic, very cheap sensor. It's precise for it's very precise for most application. If you don't need, it's like has an accuracy of 1 degree, which is sufficient for most applications. So we also explain how to control it, how to use it. We provide the code and the circuitry as usual. We can try to build this quickly, I think. It should be easy. We can add a new project here. So just gonna add the temperature sensor, and we need a breadboard. So we have 3 inputs. We have the ground, the V out or your signal, and we have the power. The V out, we can connect it to pin 10, for example. Ground goes to ground. And the power goes to 5. I'm sorry. The signal coming out of the sensor is an analog signal. We can't use the digital pins, so we're gonna need to use the analog pins. We're gonna use analog pin 0, for example. As for the code, it's very basic code. All we need is to tell the Arduino that there is a temperature sensor the temperature sensor should we tell the Arduino to read the temperature and display it on the serial monitor. We can add some color coding here. We'll make it easier. We can try to make those wires more neat. So for the code, just gonna put an variable. We can call it the temperature pen, temp pen. This is connected to A0. We need a temperature value, a variable where we can store the temperature. Make it an integer. We can call it temp value or temp val. You can call it 0 for now. That's all we need. We need to start our serial monitor with the function serial.begin. In our course we explain how to use the serial monitor. I just skipped this lesson. We can tell the Arduino that the temperature pin is the input pin. So we're gonna pin mode temp pin gonna be an input. Okay, the next step is to to read this digital to read this temperature and store it in the temp val variable. So we can say temp val is equal to analog read. Analog read, we're gonna read from temp pen. The next step is to display this reading. We display it with the serial dot print. Sorry. Temper. So this should be enough to run this code. Let's start. Okay, this is from the previous loop or the previous code. There was an extra curly bracket. Okay. So the temperature sensor is reading 0, and there should be a slider. Okay. It's not. It's always reading 0. So there is an error in the code. Can anyone spot it? No one? Okay, you can stop the code. And Let's try again. It's not in the code. The problem is in the hardware. We forgot to connect or to bridge this gap. It's not connected. So we need to break this. Stop, connect this way, and start. Now it's reading values. Please note that these values are not they are not a degree. It's not in degree Celsius. From the datasheet of the sensor, there is a function that can transfer the reading of the sensor to the actual temperature. So this is just a resistance reading. It's not the actual temperature. We need to map this readings to the with using a mathematical formula to transform it to the temperature. After the temperature, we explain. We add more exercise. We increase the difficulty, or we increase the functionality of the sensor bit by bit. We can add an LED to make an alarm, for example. If the temperature goes above a certain level, the LED should turn on. Or if it's it's back below that threshold value, it will close again. And so on. We explain data types and and how to use each data type and where to use it. Then after that, we continue explaining all of this. We explain LCDs and how to use them. We're just gonna skip to servo motors really quickly using the handy lesson plan. Okay, servo motor. As Youssef explained earlier, servo motor, we use them in animatronics, for example. They are more precise instrument than DC motors. DC motors are constantly rotating. Servo motor, you can control the angle of the servo motor. Some servo motor, even you can control the speed of how they go from point A to point B, and you can control where is point B in a 300. And some servo motors, operate on from 0 to 180 degree, and other servo motors rotate continuously. Servo motors also come in all different shape and sizes. They can vary in operating load. For example, this small DC motor SG90, it's just gonna handle 90 grams. Some servo motors like this bigger one can handle up to 5 kilograms. Other can carry up to 25 and 30 kilograms. Where we can use servo motors, it's very versatile. We can use it, like Youssef mentioned, in animatronics, robotics. We can also use it in RC airplanes, where we can move the control surface of the plane, the wing, for example, or the tail wings. They are on the RC hobbyist world. They are controlled by servos. RC trucks or RC race cars, they also control. The steering is controlled by a servo because we need precise control. So the servo motors operate on a library, or it's a library is a set of code that makes it easier for the end user to communicate with whatever device it's communicating. So, for example, a servo or an LCD display. It just makes it easier. Um, so in this example, there's just a servo motor. We can, I think I already made an example for this. Sorry. Yeah, so it's very basic. We have the servo motor and the Arduino. So this is the blue one, the small servo motor. You can control this with the Arduino directly because it's small. But the bigger servos, you're gonna need a driver. Some drivers, there are some driver in the market that can control DC motors and servo motors at the same time, and there are some made specifically to each one. So the servo pinout and are very straightforward. We have a ground pin, we have a signal pin, and we have a power pin. The power goes to the 5 volts, the ground to the ground, and the signal goes to the one of the pins on the Arduino. In our case, we chose pin 9. Sorry about that. As for the code, it's very straightforward. We include our library, servo library. Then we define our servo. We make an object. We call it my servo. We define the angle of the servo for a variable where we can store the angle of the servo. For example, if you want your servo to go to angle 90, you tell it to go to 90 degree. Then in the void setup, we tell the Arduino which pin the servo is connected to. Using this function, myServo.attach pin 9. If it was attached to pin 10, we're gonna say servo.attach to 10. Here it's a very simple example of loop. This code will make the servo sweep. Goes from 0 to 180 and from 180 to 0. So the loop start at position angle 0. The position increase by 1 degree until it reaches 180 degree. So if every time the loop increments plus 1 degree, we write it to the servo. So it starts 0, 1, 2, 3, 4, and so on. We put a small delay here so it doesn't move very fast. After it reaches 180, we decrement. We go negative. So from 180, well, 179, 178, and so on. So we can give this a try. So this is working. So yeah, this is a very simple, very basic use of your servo motor. For example, this can be used to wave a hand of an animatronic, for example, if you're using, for example, a sensor and you want to detect in a field of motion or a field of view, you can move the sensor from right to left and so on. So another example would be if you want the motor to go to a specific angle, we're gonna delete those loops. Don't need them. You can just tell the servo to go to a specific angle. For example, angle 10. There it goes to angle 10. We can tell it to 150, for example. And it goes to 150, and so on. So this is basically a quick view on the course and explaining the motors and motion. After that, we continue with more complicated examples, how to control two servos simultaneously, and so on, and then how to integrate the servo with another sensors, for examples, and DC motors and servos at the same time, and so on. So I really hope you enjoyed this presentation. I had a lot of fun explaining it to you guys, and I hope you really enjoyed it. Thank you, Youssef, Murtaza, and Sandy for this opportunity. Uh, I really enjoy working with you guys, and I hope you had fun.
Thank you so much, Abdulaziz, for sharing all your knowledge and all patiently sharing each and every step. Really enjoyed the whole course. And if you're wondering from where Abdulaziz was presenting, that was through the Robots Got Talent Arduino Discovery course. So you can always go back and have a look at the whole course and do the step-by-step uh, uh, part. So now try to open up Tinkercad. So the stimulation was in Tinkercad. So you can open up Tinkercad in one window and then try out the step-by-step Arduino Discovery course from Robots Got Talent. Up next is me, and I'll be sharing about Arduino teaching strategies and in general Arduino in education. Uh, so let me share my screen. But before I share that, I wanted to share one of my projects, which was based on what Abdulaziz shared. So last year I did something called as Fab Academy, where we had to look at how uh, how would you connect an Arduino to different DC motors. So Abdulaziz shared with you like how to connect different DC motors and a servo motor. So what I had done is I mapped out X carriage and a Y carriage, put it on an aluminum frame, and then so this is the motor driver. So I took the L298 motor driver, connected three servo motors. As because these DC motors require high power supply, I then connected a 12-volt power supply to it, and then I had a servo motor also connected to this. So what I did is I laser cut a pen holder and then 3D printed uh, this mechanism for it to move up and down, so to the pen up and pen down. Uh, so this is if I would show the video, hopefully that plays, yeah. So that's this was a part of the machine design week. So I had to design a machine right from scratch. So this was a CNC plotter. In terms of coding, what I did is we basically code with X and Y coordinates. So you have something called as GBRL, which is converts your code into G codes and M codes so that you know where the point to move it. So I took the Arduino board, converted to G code, then sent it to the machine to then move the points. To use ChatGPT to actually find out how the calculation works based on the pulleys and the gears, uh, which would have been a nightmare to actually find out without understanding the pitch and the microstepping of the motor. So yeah, this was a project, yeah, quite a fun project. All the steps are mentioned up here. Please feel free if you really need any more guidance on how this project was done. I'm more than happy to do that. But this was a practical application. Once you have gone to the Arduino Discovery course, you have looked at how DC motors work, how servo motors work, then what can you make a real life machine out of that? Uh, yeah, that was one of that. So let's now go to my presentation.
Wow, that's an
So quick
amazing
background.
project. Thank you for sharing this,
Thank
Murtaza.
you. Thank you, Youssef. Just a quick background about me. I'm based out of UAE, and I work with Youssef as the education director for Robots Got Talent. No, 50 years ago, there was a news report which said computers are making very slow progress in the classroom. And at the same time, there is this Moore's law where transistors on microchips are doubling every year. We are looking at what NVIDIA is doing with AI and how it's going to revolutionize the whole education business. A few years ago, I was not a part of this project, but I was actually in the room when this was getting built from scratch. I was doing some winter and summer camps. This is the Hamdoun Fab Lab in UAE, and this is the world's largest Arduino board. I even had a chance to meet David Catalyst, who's one of the co-founders of Arduino. And this was like a real life board of Arduino. I'm not very sure if they have it here. It was pre-COVID, but yeah, it's available. It was available in UAE Fab Lab and Hamdan. So if any of the UAE participants are here and you want to go have a look, yeah, might be worth checking in. This is small
One of the most fulfilling parts about being a
Arduino
teacher
in
is teaching
education.
young people how to problem solve and take control of their own learning.
My science and technology students find it easier to understand what they learn when they can actually see how it links to the real world.
I cannot overstate the importance of learning to code. It's a skill that's being used more and more in jobs, so getting students started as soon as possible is crucial.
The Education Starter Kit is really good fun, and it means my students want to learn. They're getting to grips with science and technology, they're engaged in what they're doing, and they want to succeed.
I think that the Explore IoT kit does a great job at linking classroom learning to the world around us. All the projects are based on
That was a quick overview of Arduino in education, which is available on the Arduino website. But I wanted to kind of do a recap of yesterday. What you see on my screen is the Arduino R3. And what a lot of educators do not know is there's a whole learning path about how Arduino in education works, how it would use Arduino in robotics and science and Internet of Things and in coding. And these are the two new products. On the left, you see the Arduino R4 Wi-Fi. I'm myself pretty excited with the R4 Wi-Fi. That's because it also it has a low power chip, but it also has a ESP32S3 from Espresso. And on the right hand side is the Arduino make and plug kit. A lot of time, my challenge with Arduino in education was that Arduino was designed for hobbyists, right? So Arduino 20 years ago, Mazima Bazmi and David Catalyst, they were teaching in the University of Irene in Italy. And a lot of time, the electronics that time was like closed, expensive, very difficult for students to use. So they wanted to have something which was easy. So that's why in 2005, they designed the Arduino Uno board, made it open source. So they have an open source transparent policy right from the IDE to the hardware. And that really kicked off the whole makerspace and making industry. But still, it was for K-12 segment. It had a lot of challenges in terms of teachers being utilized. What I'm very excited about the Make-in Plug Kit is the Arduino quick modules. So what you see on the top are different Arduino sensors, but they are plug and play. So it goes on this quick connector on the right hand side, and it also has an LED screen. That makes it very easy for Arduino. Now, you saw Abdelaziz in the last one where he was using Arduino or text-based coding, but in Tinkercad, you can also then change from text-based to block-based coding. And that kind of opens up low age group students to then use Arduino just using scratch blocks. Just to give you a comparison of what Arduino R4 and Wi-Fi and SMD is, and you would have, if you were here yesterday, you would have seen this on. But yeah, the quick connector, the LED matrix board, and the whole expressive ESP32 then opens a Wi-Fi and Bluetooth module to it. Now, just focusing on the entry-level solutions, which is the Make and Plug Kit, there is a whole coursework which Arduino has put in, and how would you utilize that? But that goes for your Internet of Things. Then you can move to your Arduino Cloud for education, or you could just go for the Arduino Uno as a starter kit. So these are the two options. If it was me, I would just spend those extra few dollars to actually buy the make and go the plug kit, because you get those 6 sensors at a good price to then kind of have whole ecosystem to teach Arduino in your classroom. This is something which a lot of teachers don't know, and for me, even I wasn't really had never gone and explored this a few months ago. But Arduino actually now has a whole teacher resources. So example here is the science lab. You have a physics lab kit where you could teach the whole of physics, right from pendulums to acceleration, motion, light, all of that. But it also has then the whole lesson plan and a student worksheet. So students would then, what you see over here is on the right hand side is an overview of the lesson plan, like how much, it's broken down into each minute, like how much time would you then spend on each minute, like even taking the component that would take 1 minute. So they have kind of broken that down. So it takes around 90 minutes to complete. So you would do it in like 2 block lessons or two sessions. And on the lesson plan itself, if you're doing it in 2 different sessions, they've given a half like, okay, this is where you would stop half time and then you would continue in the next week. So do check out these lessons resources. From the K-12 segment, all the Arduino courses are free. There are a few paid courses which are for the IoT Rev 2 and CTC kit and the engineering kit. You did see Abdelaziz look at Tinkercad, but Tinkercad also has a whole lesson plan overview of how to use Arduino, and it's also mapped to a lot of curriculums. Apart from the Arduino Uno, so a lot of us only know about Arduino with Arduino Uno board, and that was the case up to 2017. But then Arduino came with these different boards. So what you saw Youssef use was the Arduino Mega, which is a little bigger board, which has more inputs and output pins. But Arduino also has these wonderful science kits, the physics lab kit. What you see on the right is the robotic arm, and it also has a whole coursework which goes along with that. And then they have the Arduino Nano, Arduino IoT bit, and so on. So definitely something worth checking out. Now, this was released, I think, 6 months ago, and it's one of the kits which was designed right for education. Like everything about this Arduino 𝐴𝐵𝐿𝐵𝐿 is only designed for education, whereas in most of the other ones, the idea was open source, hobbyist, and then imported into education. Arduino 𝐴𝐵𝐿𝐵𝐿 uses an Arduino ESP32 Nano form factor board. It has Lego connectors on both sides. It is a compact robot. It can work on plug and play, so you can use it right from your grades 4 and 5. It has the quick connector. It has servo motor expandability, and then can integrate with 3D printers in terms of designing add-ons for it. So for the drag and drop functionality, you could use the 𝐾𝐫𝐝 IDE. They have a for you to then program the Arduino 𝐴𝐵𝐿𝐵𝐿. Again, something which is under the hood, which a lot of educators do not know, is Arduino has something called as a project hub, where you can then look at different lesson plans. So this is an example of different lesson plan where you look at, okay, how would you make a button clash or like a quizzing platform? But again, what a lot of teachers need is those step-by-step help. So, okay, this is the introduction of the project. These are the components. These are the tools, apps, and the project description and the code. So, think of it as instructables, but on the Arduino platform. So, and they have kind of highlighted the ones which are great for school projects. These are from Arduino as well as from other community educators around the world. So definitely something worth looking at. So a lot of schools buy an Arduino board and then end up like, okay, going on Google and searching, but a lot of that is still based on the makerspace and hobbyist community. But what I see on the Project Hub is based on the education community. I'm a bit conscious of time, so I'm rushing over a few of these things. This was explained yesterday in the recorded video about how the greenhouse kit or the science kit is, and the science journal. Again, it's a science journal is a great app where you could then look at data logging and IoT uh, or coding together to kind of look at understanding of light, acceleration, motion, gyroscope, and so on. Now let's come to teaching strategies. Now you have for education, if I had to like literally put down into two buckets, you have the Arduino Uno, and then you have the Arduino Alvic, which are your two go-to kits for education. Uh, both of them, if you're going with the R4 plug and make, both of them have the ESP32, so both of them can be then expanded into the IoT bit. What you would do is if you have a lab and you have dedicated computers, then you can go and use the offline version of the Arduino IDE. But if you're like on mobile devices, Chromebooks, or going coding on the go, then you have the Arduino Create or Arduino Cloud, where you could then program right over the cloud and do an OTA update. Now, the free version allows you to have two codes and two things on the dashboard. But the Arduino School app, which is approximately $20 per user per month, allows you to have like 24, 25 different options on there. So again, look at your needs. If you have offline availability, use the offline one. The online one, you can create dashboards and stuff. If you are on mobile and you want to really maximize distance learning, hybrid learning, then look at the Arduino Cloud option. It also allows you to then integrate to Google Classroom to then sync projects, send worksheets to students as well. So that's the hardware and the components. The online learning content is the coursework. So if I just show you the coursework, this is something which a lot of educators do not know, but this is the whole coursework. And if you see, most of the courses are free, except what I told you is the IoT Ref 2 one, and then you have paid courses for the CTC kit also. What's interesting is we are all aware of the Arduino IDE, which has been there from the last 20 years, but Arduino has also released something on Arduino Labs, which is Arduino Lab for MicroPython. Again, they have a coursework. So if you're teaching MicroPython or Python programming and you want to get them introduced, the whole course of Arduino MicroPython's 101 is great for them to get used to. And both the Arduino Uno, R4, the Arduino Nano, ESP32, Alvic, all of that can be then programmed via Python. So if that's the route you want your kids to go, you can then program by Python. If you're teaching ICSE or if you're teaching C++, then you would then go with the Arduino IDE. So these are the two programming actions, Python as well as C++. Of course, both of them is preceded by the drag and drop coding with Arduino Alvic. Now, this is this was an example of like when you go inside the course. This is how the teacher good luck. Like, okay, you're designing a centrifuge, so this is your linking to your curriculum. So if you I've opened the physics lab kit, so directly links to the physics, and a lot of time physics is taught theoretical and centripetal force, right? So kids then can get confused, is it inward force and outward force? So with this, they kind of see that happening in real life. So this would be useful even for your labs as well as like an extended learning activity for the students. And you have the material list which you need for that. You have the learning outcomes, your hook video, the setup with step-by-step photographs. And these are like for example, to do this setup, it hardly takes around 6 to 7 minutes. So again, a great way to get them started into education and Arduino. Now, the last level is your AI and real world application. That's where Arduino Cloud comes in. So if you're interested in Arduino Cloud and AI and IoT, wait for the next session. Abdelaziz will be sharing some of his insights on AI and IoT. And lastly, the whole community. Arduino was designed as open source, and it's always going to be open source, where a lot of amazing members from the community share their work. So these are the four core principles of Arduino's work. This is an example of, again, from the science lab, talking about how it's linked to the UK national curriculum. So you have the curriculum mapping and the standards. So if you're wondering, okay, how do I get Arduino in my curriculum? Do I need to design lesson plans? Do I need to do a curriculum map? All of that is pre-available on the Arduino website. Last but not least, the Arduino Junior certification. Again, kids need that kind of validation on their skills, and Arduino Education Starter Kit and the Junior certification is great for 14 age plus, which will help them not just to get more confident, but also help them to understand the nitty gritties of using Arduino in there, and it will also help them in their universities. Just to wrap up, the Arduino RGT course is available on the Robots Got Talent website. Please do make some time to check out that course. And that was all about Arduino in education, and a few teaching tips. If you have any questions, please feel free to reach out to me. Thank you, Youssef, for this opportunity. My email address is up on the top. Make a Murtaza at bitandbrick.com for any questions. Thank you. Uh, Over to you, Youssef, for the next part of today's session.
Great. Thank you so much, Murtaza. That was a great presentation, and thanks for your time and effort delivering this. That was amazing, and a lot of tips and like insights that I didn't even know. So thank you.
Thank you so much.
Thank you. So right now we're having our Arduino IoT Cloud session. Since we thought like a few of you would be interested to learn more about the IoT Cloud, we've added this simple pre-recorded tutorial by Abdelaziz. So he will just guide you through the IoT Cloud. So we'll just be playing this video right now for you.
Hello guys, and welcome to this quick tutorial. Today we will show you just a very quick and simple tutorial on how you can use the IoT Cloud or Arduino Cloud. It's a very interesting tool. I hope you like it. Okay, so first of all, you need to create an account, of course. Then you need to have a microcontroller that supports internet, whether an ESP32 or a Arduino Giga, for example, or an Arduino with Wi-Fi capabilities. We'll go to the devices tab and you select add a device. Then you have two options. Either it's an Arduino board, it's like made by Arduino, or it's a third party like an ESP32. Today we'll be using an ESP32. So you select an ESP, so ESP32, then you select your model. This happens to be the model that I have, so I'm gonna choose it. Connect, continue, give your device a name. Let's go with Zelda. These are very important: device ID and security key. Security key, it's used to connect your microcontroller to your local Wi-Fi network. So you can copy them, and you can also download the PDF. I have saved and continue. Done. Then the website will take you to this page. You can monitor your device activities, You can do live the past 15 days and so on. After we configured our device, now we need to add a thing or the project that the microcontroller will control. So we add a thing. They will just control an LED, nothing more. Make it uh, turn it on and off with a button. So here we have cloud variables. There are a lot of variables you can select from. You have basic type, the boolean, floats, and integer. We are familiar with that. There is energy, capacitance, electrical resistance, and so on. Force. Also there is light and color. This is used to control if you want to uh, if you want to add a smart home integration with the ESP or the Arduino. Those are more sophisticated variables. Today we will go with just a boolean. So read and write. You need to give it a name. Let's name it status. Right. Add a variable. Now we have a variable called status. This is will be the button status. Okay, and this thing or the project. So now we need to add the microcontroller. This is an old one. It's an old microcontroller I have, and this is the one we will be using today. In this page, if you have more than two, or if you have five or six microcontrollers, you can choose which one you want. Then we're gonna connect it to the network, your local network. Here you're gonna type your Wi-Fi credentials, and here you're gonna type the security key we copied. It's the when we first configured the device, this where you put your security key. Okay, so I will do this step and come back to you. So after you configured your network and added your variable, then we go to the dashboard. This tab dashboards, it is where you can uh, configure the what will you see. For example, it's called Untitled. We didn't give it a name, so we can go to Edit. Here we have the laptop or PC view, and we have the telephone view. There is an app you can download it to monitor your variables or your projects on your phone or your laptop. We'll stick with the laptop. Oh, here all the thing you can add. You can integration, visualizations. Here are gauges and charts, percentages, annotation. You can add an image or notes. We will just stick with the push button for now. You can add a push button. Here you link a variable. So you need to go to the project or the thing you're working on and select a variable status. Then link a variable. Okay. And done. Push button. I think we can rename it. Settings, name. Let's call it LED. Is it on or on off? So we click done, and you press here. Let's press unplug. So when it's pressed, the LED should light on, and it's unpressed, the LED should turn off. So this is the basics. You can add other stuff. You can add switches, sliders, stepper. Like you can count 1, 2, 3, 4. You can add values and so on. So after this, we can go to things. Choose the project you're working on, Untitled. Here we can go to the sketch tab. Here in the sketch tab, you can enter your code. For example, you will find it's already pre-programmed with some lines. The Arduino auto-generated it. Yeah, so as I said, the Arduino Cloud will generate some function. It will include a library. This is library. It needs it to connect to the internet and do stuff over the internet. I'm not particularly sure what this library does, but it's needed to the ESP or your IoT device to connect to work properly. In this tab here, you have the author, the date you created it. If you have an email, you can type it. Just steps how you can mimic or replicate this project. And thing property tab. Here it's more library. It's already included your device login name, the one the website gave you at first. And here are some functions that enable the internet communication. Sketch secrets, it's where your network and security key uh, credentials are exist there. So here we just need to do some modifications, small modifications. We need to create the LED. So I'm gonna make a variable. It's an integer. Let's call it LED pin. And let's connect it to pin 13, for example. And column. And the void setup. We need to tell the ESP or the Arduino what to do with this pin. So we're gonna do pin mode. LED pin. It's an output. So in the void loop, Arduino cloud.update. Here this is a function that tells the Arduino to send data over the internet. For example, if the button is pressed, the Arduino will run this function. I would get the new updated value if it's 0. We have void another function here. It's all on status change. Status is the name of the variable we give it. So, for example, if it was an LED, it's gonna be, if we named the variable an LED, it's gonna be on LED change. So what will happen when the button is pressed or when the variable is pressed? What will happen? We need the LED to be on. So we're gonna digital write. LED pen I. And semicolon. So this will, if the button is changed, the LED pin will be hot. We can add, for example, we can add a delay for, let's say, 2 seconds. Then we can make it
So thank you so much, Abdelaziz, for conducting this quick tutorial. We will be uploading longer, more detailed tutorials soon to our YouTube channel and RGT website. So now that's the great part of our workshop, is the questions and answers. So does anyone have any question about any of the things covered through the course content yesterday and today?
Yes, I'm also here, Sandipan. If anyone has any kind of questions regarding any projects, please let us know.
Okay, it seems like there are not a lot of questions today. So let me just guide you through the prior workshop details. So of course, you know that there are certificate participation certificates for everyone who have joined us through this 2 days workshop. And these certificates will be sent to you within a week after filling the form that we will share with you now. So you just have to fill this form and then
Submit it, and your certificates will be delivered to you.
exactly, yeah, via email.
Via email. So
Yep.
please look into that.
I've pinned it to the chat. Also, all these sessions are recorded and will be later uploaded to our YouTube channel. As we've mentioned, thanks to Abdelaziz, this course would be available with no login required through March and April. And for everyone who have Sandipan, please turn off your mic. The noise is really unbearable. Thank you. So the passcodes for the Arduino Discovery course, the second version, will be all sent to you. Everyone who joined us through this event will receive the new codes unlimited, so they could access the course forever. That's just a little gift from us to thank you for joining these webinars and to show appreciation for the effort that you're making to improve your teaching skills and discover new things about Arduino and robotics. So again, let me finish by thanking the great team. That it's always my pleasure to be a part of this team. I want to thank Sandipan. This event was his idea, and he signed us up for the Arduino Days. So thank you so much, Sandipan, for all the efforts that you've done conducting this meeting and preparing for it. Thank you, our amazing educational director, Murtaza, for his effort today and yesterday, and always keeping up with us and coming up with amazing ideas that help us reach more people and improve our goals and actually do a change in the educational robotics community and reach more people. Thanks, of course, to Abdelaziz Hamdoun, the head of the course development team, for all the amazing work that he's done today, yesterday, and the things that are still under constructions. There are lots of surprises that will be coming up this year and next year related to Arduino, IoT, ESP32, CAD, a lot of things. I just don't want to break the secrets. Again, after all, we just want to thank Arduino again for giving us the chance to organize this official workshop. And thanks for you guys for joining us today, and for everyone who joined us through the 2 days of the workshop, and for anyone who even just signed up for participating in these workshops. So, Sandipan, do you want to add anything?
Yes, so of course, I would also love to um, think about how Arduino is really making a lot of progress, and Arduino is something that is really life for us, all the makers and the researchers all over the world. They're giving us a lot of opportunities that we really need and require to work with our ideas. And without Arduino, it would be really impossible, at least Arduino's ecosystem. Without that, it would be really impossible for us to create any kind of starting, at least for the starting point, we really need Arduino to start prototyping our ideas. Um, Thank you so much again to the Arduino, and we really happy to celebrate this opportunity. Happy birthday to Arduino, and happy anniversary to Arduino 2. And all of you, especially Mr. Youssef, founder of and president of Robots Got Talent, Murtaza, our education director, and Abdelaziz, our master and education course developer, and also he is a very good guy and very skilled person, and one of the best makers too. So, and also all of you who have sticking with us till now and be a part of our journey. We really happy to announce that we are so happy to host all of you, and I hope all of you enjoyed throughout the sessions for 2 days. Thank you so much again and again.
Thanks, everyone.